Good morning, everyone who is joining with us on Zoom, and welcome to a special lecture on application of deep neural networks for Scour modeling. My name is Tanchanok Onlamoon, an International Relations Officer of the Faculty of Environment and Resource Studies at Mahidol University, performing the role of the MC in this session. It's nice to meet all of you. As for this special, we are pleased to have Professor Mohammed Sharif as our speaker for today's special talk. But first of all, let me share with you a brief introduction of our honorable speaker. Professor Mohammed Sharif is currently Professor of Civil Engineering at Jamia Millia Islamia Central University in New Delhi. He received his PhD degree from the University of Edinburgh in 1999. His PhD program was funded through Overseas Research Scholar Award, administered by the Scottish Council for Higher Education. Professor Sharif has over 25 years of research, teaching, and consulting experience in water resources management. His primary research interest focuses on hydroclimatology, sustainable development, and application of the systems approach to management of complex water systems. Today, Professor Mohammed Sharif is sharing with us his knowledge and insight into the application of deep neural networks for Scour modeling. Without further ado, please join me in welcoming Professor Sharif.
Dr. Gampanath Bhaktikul for giving me this opportunity to interact with you on this occasion. Today's talk is on the application of deep neural network for Scour modeling. Now, Scour is basically flow-induced erosion of soil particles around bridge piers, and during times of flood, the process of scouring gets exacerbated, and it is because of the importance of Scour that we should look into methods to predict the amount of scouring. So there have been different techniques that have been used for Scour modeling, but today I shall be speaking on the application of deep neural networks for Scour modeling. So this is how the lecture for today has been organized. First of all, we will look at what is Scour modeling. And then, because deep neural networks involve some sort of optimization, therefore we will look at optimization and how even Microsoft Excel can be used to solve problems related to optimization. Then, since the results of deep neural network have to be compared with regression equations, so we'll also discuss regression models. Moving on, we'll discuss artificial neural networks. And then finally, we'll come to deep neural networks. And I'll also try to show some Excel-based implementation of deep neural networks. So the first part of the lecture is on Scour modeling. As I told you, Scour is the flow-induced erosion of soil particles around bridge piers, and this becomes quite predominant during times of floods, because during times of floods there are high velocity waves and currents. So the scouring phenomena is a complex phenomena because of the involvement of large number of variables that affect the phenomena of Scour. And the relationship between the predictor and response variables is mainly nonlinear. So it's not straightforward to predict the depth of Scour around bridge piers. Now, if the Scour is too much, then obviously it would lead to failure of the bridge and failure of the pair of the bridges, and ultimately it would lead to failure of the bridges. So that is why the importance of Scour cannot be overstated. A large amount of research is currently being carried out to predict Scour depth around bridge piers and abutments. So with this picture, you can see that there is erosion of the particles, soil particles around the bridge pier. So this phenomenon is called scouring. And this occurs due to hydrodynamic impact of water. And as I told you, the impact becomes even more predominant during times of flood. Now, when the experiments are conducted to determine the extent of scouring, then basically laboratory setups are created. And this is one of those setups. This is a circular bridge pier model. And this is you can see here how the scouring has taken place in the lab. So we can look at how the scouring is impacted by the soil type, by the velocity of flow, crowd number, for example, and also on the type of the pier, whether it is circular or a square. So different types of arrangements can be made in the laboratory, and then we can have this type of experiments to determine the amount of scour. And then normally what many researchers do is they try to relate different variables with the scour depth using some sort of regression equations. However, the phenomena is very complex and the regression equations may not always be giving us highly accurate results. So that is why the machine learning techniques like artificial neural networks or deep neural networks are being explored these days. So we'll discuss how deep neural networks can be used. Now, this is how the flow patterns are around the bridge piers. These are surface wakes, scour hole. So this is just a graphical representation of how the velocities of flow are. Now, what is the importance of Scour modeling? Design of bridge piers and abutments is significantly impacted by hydrodynamic processes that cause scouring of the foundation. Therefore, scour around bridge piers has to be investigated. And it has been scouring around piers has to be investigated, and it has been found to be the major cause of failure of bridges. Determination of scour depth is a prerequisite for the design of various hydraulic structures. So various hydraulic structures, when they are designed, then we also need to determine the scour depth. Scouring exacerbates during floods and high flow events. It means the scouring becomes more predominant during floods and high flow events. There are many empirical formulae that have been developed for determination of the depth of scour. However, these empirical formulae, they suffer from several limitations. So there are several limitations of the formulae. For example, different researchers have used different independent variables to determine or to predict the depth of Scour. So there is no uniformity in the use of independent variables by different researchers. Empirical formulae are largely applicable to the hydraulic conditions for which they have been developed. So for different hydraulic conditions, you cannot apply the same formula. So the empirical formulae that have been generated or that have been developed are applicable only to the situations for which they have been developed. So there are several limitations of the empirical formulae that are available in the literature. So that is why we are investigating the use of deep neural networks in predicting the depth of Scour around bridges. Now, the traditional methods for the prediction of Scour around bridges, bridge piers, and abutments is based upon experimental investigations. So if you have to determine the depth of scouring for a bridge, then what we normally do is we create a setup in the laboratory, prepare a model of the bridge, and then try to create the conditions similar to the conditions actually there at the site. But this is a very time-consuming phenomena, and it's costly also to set up the experimental infrastructure in the laboratories. Although empirical formulae are there, but the reliability of empirical formulae is also not very good. So because there are limitations or problems associated with experimental and theoretical estimation of Scour, there is an interest in the use of artificial neural networks and deep neural networks. So this is the area on which we are working these days. Now, in order to apply deep neural networks, we need to optimize certain parameters. So basic knowledge of optimization is required. That is why I want to discuss a little bit about what is optimization also. So optimization is the process of obtaining the best solution of a given problem under given circumstances. Now, optimization is being used to solve problems from a wide spectrum of fields, ranging from engineering, medicine, economics, among others. So there is no field nowadays where optimization is not used. Even in the stock market, optimization is used. Optimization algorithms are becoming increasingly popular in engineering design activities, primarily because of the availability and affordability of high-speed computers. Earlier, the problems which were considered to be difficult to solve are now being solved mainly because we have high-speed computers available to us. Now, these are some of the areas in which optimization is being used in the field of civil engineering: design of structures, buildings, trusses, dams, chimneys, optimal route planning for disposal of solid waste, design of water distribution systems, optimal operation of reservoir systems. Basically, here we look at how to operate the reservoir optimally so as to get the maximum benefit out of it. Project planning and scheduling. So these are only some of the areas that I have listed here. There are a lot more areas where optimization is being used. Now, just we'll try to understand some optimization terms. Now, decision variables are the variables that affect the performance of the given system. So in any optimization problem, the first step is to identify the decision variables of the problem. So we have to look for the variables that affect the performance of the system. So those variables are called decision variables. Once the decision variables have been identified, we formulate a function of the decision variables of the problem, which is known as the objective function. So objective function basically relates the decision variables by a mathematical function. For example, the objective function could be to minimize the cost. So in that case, we have to relate or express the cost in terms of the decision variables of the problem. In some other cases, we might want to maximize the profit from a given activity. So there also we need to express the appropriate measure of performance of the system by some mathematical function of the decision variables. Now, whenever we are trying to maximize a function, we can have a very high value or infinitely high value of the function, but in practice, it is not possible because there are always some constraints on the function. So constraints are the restrictions on the values that can be assigned to decision variable, typically by means of equalities or inequalities. So the constraints may be governed by technical or resource limitations, or sometimes by some political reasons. For example, in the operation of reservoirs, maybe one state doesn't want to release water to other province. Okay, so one province may have some requirements of their own. So that type of limitation is called a political limitation, basically. So there are restrictions on the values that can be assigned to the decision variables. So these are known as the decision variables of the problem. Now let us look at one optimization example first. So if you could read this example first. 20 million meter cube of water is available in storage for irrigation of the two crops. Now crop A requires 9,000 meter cube of water per hectare of irrigated land and produces a net income of $720 per hectare. Then there is crop B, which requires 6,000 meter cube per hectare and produces a profit of $1,200 per hectare. Now crop A can be planted in a maximum of 1600 hectares of land, whereas up to 2400 hectares of land is available for planting crop B. The decision problem is to determine the amount of land to be planted in crop A and crop B that will maximize income within the constraints of limited land and water resources. So the problem here is to formulate and solve the optimization model to determine the amount of land planted in crop A and crop B that will maximize income in dollars. So maybe you can have a look at this example here, and then we will formulate this into a mathematical model, and then we'll try to solve that. So first step, as I told you, is to identify the decision variables of the problem. So let us see what are the decision variables for this problem. So the decision that you have to make is that how much land is planted in crop A, and what is the amount of land planted in crop B. So this is what you have to actually find out. You have to find out the value of x1 and x2. And if you are having x1 as the amount of land planted in crop A, for each hectare, this is in x1 is in the x1 is the area in hectare. So for each hectare, if you go back here, there is an income of $720. So for x1 hectares, the income will be 720 x1. Similarly, for crop B, for each hectare, you can see here, there is a income of $1,200 per hectare. So the objective is to maximize 720 x1 plus 1200 x2. So you have to maximize this value of this function. So we can give large values of x1 and x2 and z will be maximized. But there are some constraints of the problem. For example, x1 should be less than 600, x2 should be less than 2400. And also there is one more constraint you see here. Crop A requires 9,000 meter cube of water per hectare and crop B requires 6,000. So 9,000 x1 and then 6,000 meter cube is the amount of water required per hectare of crop B. So 6,000, and this should be less than equal to the total less than equal to 20 million. 20 million. 1, 2, 3, 4, 5, 6. So this is again a constraint that the total available water is 20 million meter cube. So we have to satisfy this also. So there are three constraints basically, which we have to satisfy. And we have to maximize this function. Okay. Now this can be done because this is a linear programming problem. So this can be solved using linear programming. So linear programming problems can be solved using a program which is available in Microsoft Excel. It is called Solver add-in program. So the Solver add-in is a Microsoft Office Excel add-in program that is available when you install Microsoft Office or Excel. If it is not available, then you can install it. So to use the solver add-in, you need to first load it in Excel. And solver add-in program can be used to solve linear programming problems. And to some extent, it can also be used to solve non-linear programming problems. However, it is highly reliable when you use it to solve linear programming problems. But the program is not as highly reliable when you are dealing with non-linear programming problems. In the SolverX add-in program, there is an option to solve relatively complex problems using evolutionary option as well. So this is the window for that is the screenshot of the solver, but I'll show you how to set it up on Excel. So if you go to Excel and you have to go to options to set up the add-in program. You click on add-ins and then these are the add-in programs that are available. So to set in or to load the program, you need to click and then you need to click go. Okay, like this. Then you will come here and then solver add-in I've already added. So if it is unchecked, you check it and then you just click OK. So like this, you will have it on your system. And then once you have it, what we will do is, I'll tell you how to solve it. So you give some values of decision variables, maybe 10, 20, any value, just start. So x1 and x2 are the values of the decision variable that we ultimately want to find out. These are not the optimal values. These are just some values. You just give any random values. And then here in this cell Z, you write the value of the objective function. So our objective function is 3x1, 720x1 plus 1200x2. 720x1 plus 1200x2. So you go here, 720x1 plus 1200x2 plus 1200x2. In this cell, I'm writing this Z. This will not be used in the calculation. Calculation will be done here in this cell. So here you write Z is equal to 720x1. So 720 multiply x1 plus 1200 x2. X2 means this value. You have to deal with values. The first row is just for your reference. It's not used in the calculation. So this row, first row is not used for calculation. The calculations are done on this row only. Now, what is the constraint we have? X1 is less than 1600. X1 less than equal to 1600. So here you just give the left hand side of the constraint. Left hand side is x1. So just give x1. Constraint 2 is x2 is less than equal to 2400. Again, here you give the, this is equal to also, less than equal to. So just give equal to x2. Just give the left hand side. Right hand side we will give later on. And here this 9000 x1 plus 6000 x2. So this is our constraint 3. Constraint 3. 9000 x1 plus 6000 x2. 6000 x2 less than equal to 20 million. 20, 1, 2, 3, 4, 5, 6. So again here give the left hand side. Left hand side is 9000 multiply x1 plus 6000 multiply x2. So I have given the left hand side for constraint 1, which is x1, left hand side for constraint 2, which is just x2, left hand side of constraint 3, which is 9000 x1 plus 6000 x2. Okay. Now we will set up the model. So for setting up the model, you go to data and solver, because solver has already been installed on the system. You go to solver. Now, first thing is here, objective. What is your objective? Objective is to maximize this value of Z. So just click here. So maximize $C2. This value, which is 31200 right now, we want to maximize this. By changing the variables, which variables we want to change? We want to change these two. Just select this, A2 to B2. I have highlighted this in yellow. So after that, I'm deleting the constraints. I'll tell you how to set up the constraints. So add a constraint. Now the constraint is this value should be less than equal to, we know it should be less than equal to 1600. 1600. X1 should be less than, add. Now second constraint is this value, this left hand side should be less than equal to right hand side, which is 2400. Again add. This value should be less than equal to 20 million. 20 million. 1, 2, 3, 4, 5, 6. I think we have set up all the constraints. So this is how you set up the constraints. Now you can use different methods for solving this problem. Now there is a nonlinear option, but we will use simplex LP because this is a linear programming problem. So now we click on solve and hopefully we should get the optimal solution. Right now the values of x1 and x2 are randomly chosen as 10 and 20. If we solve, we will get the values. Okay, you see, solver found a solution. All constraints and optimally conditions are satisfied. Keep solver solution. Yes. Okay. We can generate reports. We can look at all these things. Okay. So basically what it says is that x1 should be 622 and x2 should be 2400. So both the constraints are satisfied. You see, x1 less than 1600 was required. It's 622. And total amount of water that will be used if we use x1 and x2 as these values will be 20 million. So this is my optimal solution. So the idea was to give you some insight into using Microsoft Excel to solve linear programming optimization problems, basically. So with this background, because we can move on to the next topic. This was required because when you want to use deep neural networks or artificial neural networks, there is a parameter optimization that is required. And there we have to have some knowledge of optimization also. So we have solved, we use this type of setup. Okay, this is just the screenshots of what I have solved earlier. Fine. Now the solution that we obtained from deep neural networks are often checked with some regression model. So the next topic is regression modeling. Now, many problems in engineering and science involve exploring the relationship between two or more variables. So regression analysis is a statistical technique that is very useful for solving these type of problems. For example, in a hydrological process, it may be required to develop a relationship between rainfall and runoff. This is a regression problem. Regression analysis can also be used to build a model to predict runoff for a given rainfall. So now the problem with simple regression is that you can relate only two variables by an equation. But often it is the case that there are more than two variables that are involved. And there multi-regression is required. And statistical techniques do not give very good results when we use more than two variables and try to find the relationship between more than two variables. So that is where machine learning techniques which learn by training, such as ANN, artificial neural networks, or deep neural networks are used. So in regression modeling, what is done is we try to fit a line such that the deviation of points, sum of the deviation of points from a line is minimized. So these dots are the observed values, and then this is the fitted line. And these verticals are basically the deviations of the observed value from the value obtained from the line. And then we try to see that these deviations are minimized. Some of the squares of the deviations is basically minimized. Now, based upon the nonlinear regression analysis conducted in our research, the following equation for the estimation of Scour depth around bridge piers and abutment has been proposed. ds is the depth of the Scour, y is the depth of flow. So in terms of dimensionless parameter, this is the form of the equation. U by UC, L by Y, I'll explain here. You see here, this is the equation that was obtained by conducting a regression, multi-regression basically. U is the average velocity of approach flow. UC is the threshold velocity for sediment motion. Rho is the density of the fluid. Rho s is the mass density of the sediment. G is acceleration due to gravity. L is projected length of abutment. Y is the approaching flow depth. D50 is the median grain size of the soil particles. Sigma G is geometric standard deviation of sediments. And DS is equilibrium scour depth. So these are different parameters. These are 5 parameters which relate this cover depth. So one way to find the relationship is through regression modeling. And the other way is that we try to find this relationship between these variables using some sort of machine learning technique, such as the artificial neural network or the deep neural networks. So let us look at what is an artificial neural network first, and then we will see what we mean by deep neural networks. So artificial neural networks are information processing paradigm inspired by biological nervous system, such as human brain. So artificial neural networks consist of large number of highly interconnected processing elements that work together to yield desired output. So basically the artificial neural networks, they try to mimic the working of a human brain. In a human brain also there are large number of connections, and the processing is done at a very high speed to yield the desired output. For example, we look at an object and then our brain works very fast to tell us what object it is, what is the shape of the object, what is the color of the object. So we learn it through experience. Our brain learn from experience. So artificial neural networks also learn from experience through a set of examples of input and output. Through a set of examples of input and output. With the advent of high-speed computers, use of artificial neural networks to model complex problems has increased manifold. So artificial neural networks require large amount of processing. That is why it is important to have high-speed computers. Earlier, the speed of the computers were not very high unless you were using a supercomputer. But nowadays, everybody has access to high-speed computers, laptops. And because of this, the use of artificial neural networks to model complex problems has increased manifold. Now, this is a simple ANN. So there is an input 1, there is an input 2, and using these two inputs, an output is. So to input 1, you give a weight W1 to produce output 3. Similarly and then you multiply input 2 by weight 2 to produce an output. And normally I can show you with a simple example here. Suppose you have x1, x2, w1, w2 bias b. So if you have, suppose we are having 10 here, value of x1 is 5, value of x2 is say 12. and then output, you are giving an input of 5 and 12, and let us say the output is 50. Okay. Then we want to find out some values of W1, W2, and B. Suppose W1 is 2, 3, and maybe this is 5. Any value you can take right now. So these are the values that we have to find out. This is your output. Now you need an output of 50. This is desired output, let us say. This is an output you want. And output from ANN. So what ANN will try to do is, it will multiply X1 with W1, X2 with W2, and then add B and try to find this value as 50. Try to find a value of 50. So I will write the relationship here. So here X1 is 5. It's multiplied by W1 plus W2 multiply by X2, and then add the bias, and you will get some value here. So you see, I've chosen some values and I'm getting 51. Just random values I chose, but I should get 50 here. So maybe if I make it 4, then I get 50. See, if I make it 4 here, then I'm getting 62. So the network will try to find out these values automatically to get 62 here. Now this also we can obtain using what if analysis. Goal seek, for example, is one method. Set cell to a value of 50 by changing cells this and this. This is just simple method. And then, so goal seek is there. You set any target to some value, and by changing some cells, you want to change these cells, and then click OK. Set cell. Reference must be a single cell to value of 50 by changing cells. So I think we'll have to use solver. Data solver. This value of 50. So you have to set this G12 to a value of 50 by changing cells, by changing these 3 cells. And I don't need any constraint, for example, right now. I can delete the constraint. I can delete the constraint and then constraint, and then try to solve it. So only thing is, the network will automatically try to find some values of W1, W2, and B to get the desired output. Okay, to get the desired output. So you see, it found a solution. So it's saying that keep W1 0, W2 is 4.167, and B is 0. So this is one of the solutions. So there can be large number of solutions, but this is only for one point. So in an actual network, there will be hundreds of such points, and we have to find the values of B1, W1, W2, and B, such that for almost every point, the output is achieved. That is the point. So These will be the constant for the entire network, W1, W2, and B. We will see later. Okay. So the idea is that you try to adjust the values of the weights W1, W2, and B, and you try to get the output. This is the output we get for single set of inputs. Similarly, there can be another set of inputs, but the weights will not, weight have to be same for all the data points. So then it becomes a complex problem. So like this, what is done is there is an input, then there are weights. Weights are multiplied by the input, and the summation is known as the transfer function. And then we apply one activation function to it to get the output between 0 and 1. For example, this is one transfer function. Z is the transfer function, summation of x1 and w1 plus b. And then there is an activation function A, which is the function of Z. It could be 1 upon 1 plus e to the power minus Z. There can be different types of activation function. So ANNs basically imitate the functions of interconnected neurons by passing input features through several layers of what are referred to as perceptrons. Input is transformed to output using a set of functions. So, as I told you in the previous slide, a perceptron is typically made up of three main math functions, operations basically. First is there is a scalar multiplication. Like here, there is a multiplication of xi and wi. Then there is a summation. And when you get the summation z, you put it into a function, which is an activation function. So there are different kind of activation functions. So here, this activation function, I'll discuss different types of activation functions also. It makes the output between 0 and 1. So depending upon the requirement, we have different types of activation functions. Now, so a transformation is made using a distinct equation called an activation function. Now, if we do not use an activation function, then it would really, the network would really behave like a regression model. So in order to make it more versatile and robust, activation function is used. Now I'm taking a very simple example to bring home the point of how the artificial neural networks work. Consider the task of trying to predict the height of a tree based on soil content in the ground. Okay, so this is the task. Predicting the height of a tree based upon the soil content in the ground. So there are factors that affect the growth of tree. It could be the moisture level, iron level, grain size, acidity in the soil. Suppose we collect the data about the soil content around trees and also the height of the trees. So now we have some data to work on. And next time, using this data, we can develop a neural network, and next time we don't have to, we will just give the different parameters like the moisture level, iron level, grain size, acidity, etc. And the network will give us the height of the tree. So initially you should have both the input and the output data, which is used to train the model. And then once the model has been trained, then you don't need to give the value of the output variable. Input data in the terminology of artificial neural network is called the feature, and output is referred to as a label. So the goal is to predict the labels using the features. Label means the output, and the features are the input variables that we feed to the network. So if we develop the model, then next time we will not be requiring, we will just give the values of the features like these values, and it should be able to predict the height of the tree for you. So in the Scour example also, if we give all the values of U by UC, Froude number, grain size, acceleration due to gravity, everything, and then it should give you the depth of Scour. It should give you the depth of Scour. But for that, you need to have some data. So what we did was, we collected the data available in the literature. So many researchers have conducted experiments on the Scour. So we collected the data from their papers, and then we had a database of around about 100 points, and then those points were then used to develop the model. And finally, when the model was developed, it was able to perform better than the regression model. So in all problems which involve some sort of development of relationship between different variables, deep neural networks can be used. For example, if you want to develop a rainfall runoff relationship, then you can, it's not straightforward. There are many parameters which affect the runoff at any site. So you have rainfall, you have antecedent conditions, whether it has rained the previous day or not, the slope of the basin, the soil type, shape of the basin, all those things are there. Okay. So these complex relationship can be captured by a DNA. Okay. So with the help of this example, I just wanted to explain to you what we mean by the input variables or the features. So the inputs are simply the measures of our features. For example, a single soil sample, this would be an array of values for each measurement. For example, we may have an input of 58, 1.3, 11. Now 58 could be the moisture percentage, grain size, and this is 11 is the iron content, micrograms per kg. So let us say we are giving these three values and also the height of the tree. So these are my feature vectors. And based on these, we are determining the height. And then weights represent scalar multiplications. Their job is to assess the importance of each input as well as directionality. For example, does more iron contribute a lot or a little to height? So just giving you an example. So suppose the weight is 0.2 for the moisture content, and for grain size it is 9.6, and it is minus 0.9 for the iron content. And then we can sum up all these values together to get. So first we multiply the weights, and these weights have to be determined automatically by the model. So the model will try to determine the weights. So transfer function is different from the other components in that it takes multiple inputs. So what is the job of a transfer function? Basically, the transfer function combine multiple inputs into one output value so that the activation function can be applied. So after multiplying, you get 11.6, 12.48, and minus 9.9. And then you sum it up, you get 14.18. So this sum is Z. And then this is passed to the activation function. Okay, here it's like this. So we have calculated Z without B, for example, B is 0 in this case. So Z we have calculated, and then we put that Z into some function, which is known as the activation function. Now, why do we need an activation function? So the purpose of the activation function is to introduce non-linearity into the output of a neuron. So in a neural network, we would update the weights and biases of the neurons on the basis of the error at the output. So when we give some weight, some output will be calculated, but that output may not tally, may not be same as the output we desire. So there will be some error. So on the basis of that error, we will try to again change the weights. This process is known as backpropagation. So you give some values of the weights and you get some output, but your output may not match with the desired output. So the error is there. So use that error again to go back to the weights and biases and adjust the weight and biases. So this process is called backpropagation. Activation functions make the backpropagation possible since the gradients are supplied along with the error to update the weights and the biases. So the gradients are also given like the slopes with the error to update the weights and biases in the network. So as I discussed earlier, a neural network without an activation function is essentially just a linear regression model. So it is just a linear regression model if you do not use a neural network. So there are different types of activation functions. There's a linear function, there's a sigmoid function, tangent hyperbolic function, rectified linear unit function. So linear function has an equation similar to that of a straight line, y is equal to ax. No matter how many layers we have, if all are linear in nature, the final activation function of last layer is nothing but a linear function of the input. So the range is from minus infinity to plus infinity. Now linear activation function is used at just one place, that is at output layer. So when you have some experience of the neural networks, you will come to know automatically what type of activation function is to be used. There are different types depending upon your choice and depending upon the type of problem you have. So now there are many libraries that are available. For example, there is a Python library called Keras library in Python. So that can be used to develop, train DNN. So it's not that you have to write your own code nowadays. So you just need to take help of the Python libraries. They have several codes, but you have to write a little bit of code. Or there are nowadays many software that are available. Even in MATLAB also you can do artificial neural network models. So here the linear function is like this. You give some x, you will have y as a linear function. Then there is a sigmoid function. So sigmoid function is 1 upon 1 plus e to the power minus z. Z is a transfer function. So it basically converts whatever value you give, whatever value of z you give, it converts to a range of 0 to 1. So sigmoid function is used in output layer of a binary classification, where the result is either 0 or 1. So if your output is either 0 or 1, then you can use the sigmoid function. As the value of the sigmoid function lies between 0 and 1. So if your sigmoid function is giving a value of less than 0.5, so you can consider it a 0. If it is giving a value between 0.5 and 1, then it could correspond to 1. So results can be predicted easily to be 1 if value is greater than 0.5 and 0 if the value is less than 0.5. So for a binary output, you can use a sigmoid function. This is the graph of the sigmoid function. Okay. Then there is a 10 hyperbolic function. The activation that works almost always better than sigmoid function is the 10 hyperbolic function, which is also known as tangent hyperbolic function. It's actually mathematically shifted version of the sigmoid function. Its range is between -1 to +1. Usually used in hidden layers of a neural network, as its values lies between -1 to 1. Hence, the mean for the hidden layer comes out to be 0 or very close to it. So this type of function helps in centering the data by bringing the mean close to 0. So this is how it works. You can see 0 to 1 is the output. In the case of on the y-axis, you have the output for any value of z you give. If you give a value of a high value of z in this, then you will get 1 as the output. If you give a very low value like -5, -10, then the output is, you can see from here, from this curve also, the output will be close to 0. For negative values, it will tend to be less than 0.5. For positive values, it will be greater than 0.5. Sigmoid function. 10 hyperbolic function, it is similar to the sigmoid function. The only difference is that the range is from -1 to +1 now. Then there is a ReLU function. It stands for rectified linear unit. It is the most widely used activation function. We have also used this function in our DNN model, chiefly implemented in hidden layers of neural network. Equation AX is equal to max 0, x. It gives an output of x if x is positive and 0 otherwise. If x is negative, it gives the output at 0. And it gives an output at x if x is positive. So if you give 2.4 as the value input, the output will be 2.4. But if you give -3, then it is a negative value, so the output will be 0. So the range is between 0 to infinity. So the output cannot be negative. Input can either be positive or negative, but output cannot be negative. So nature is nonlinear, which means we can easily propagate the errors and have multiple layers of neurons being activated by the ReLU function. Uses ReLU is less computationally expensive than 10 hyperbolic and sigmoid because it involves simpler mathematical operations. At a time, only a few neurons are activated, making the network sparse, making it efficient and easy for computation. So you will understand these better when you start using the deep neural network. So this is how, if you give any negative value, then the output is 0. So the output is on the y-axis. If you give any positive value, the output will also be a positive value, same value. So if you give input as 5, input is on the x-axis. If you give an input of 5, then the output is also 5. But if you give an input of -5, then output is 0. For negative values, the output is 0. For positive values, the output is same as the input. That is what we mean by activation. Okay, then now we can take a little bit of rest, and then we will start deep neural networks.
Yeah.
Right now, we will have a Q&A session. If any one of you have any questions to ask our speaker, Professor Sharif, please feel free to do so. Right, so now we will take a break, just a short break, and then we will come back to another topic on deep neural networks.
So welcome back, and now we will discuss deep neural networks. This is the last part of the presentation. So deep neural network is an artificial neural network with the difference that it has multiple layers between the input and the output layer. So so it's an artificial neural network with multiple hidden layers. In a traditional artificial neural network, there is only one hidden layer. So DNNs are capable of handling highly complex problems because there are now many hidden layers. So with the help of deep neural networks, it is possible to handle highly complex problems, and we can train our models using deep neural networks for problems which are very difficult to solve using even artificial neural networks with only a single hidden layer. So deep learning has already transformed traditional internet businesses like web search and advertising. You see, whenever you search something and when you come back the next day, if you have searched for a flight, then you will keep getting ads and notifications of that sort of related to the search that you conducted the previous day. So that is possible through deep learning. So with the advent of high-speed computers, use of deep neural networks to model complex problems has increased manifold. Because deep neural networks require a lot of computing. So now logistic regression is simply you give some values of x1, x2, and x3, and you get a value of y. And here you see we have a hidden layer. You give x1, x2, x3, they are multiplied by some weights, and then you get an output. Now this network here has two hidden layers. So some processing is done here, then some processing is done here, and finally you get an output. Now this network has 5 hidden layers. So this is a more complex network, and I have taken this from the work of Andrew Ng. So there is a very famous lecture of on machine learning. There is a lecture series on machine learning by Andrew Ng. He's from Stanford. So if you want to watch that series to understand more about deep neural networks, you can do it. So basically, deep neural network is a network where we have more than one layer between the input layer and the output layer. So that is the definition of a deep neural network. A simple neural network is with only one layer between the input layer and the output layer. But a deep neural network has multiple layers between the input and the output. A good choice of network architecture is critical for efficient performance of a neural network. A network architecture essentially represents the connectivity pattern between the neurons. So, first of all, we have to choose a network architecture. So, network architecture is represented basically by an input layer, the hidden layer, and the output layer. Now, choice of input layer is governed by the number of variables you have, the input variables. And the output layer is governed by the output variable that you have for your problem. So the choice of input layer and output layer is pretty straightforward. It's quite straightforward. So you don't have to do much in it in defining the input layer and output layer. Because the number of neurons in an input layer is equal to the number of independent variables in a problem. For example, in the Scour modeling problem, the input layer for the DNN comprised of 5 neurons, U by UC, L by Y, sigma G, FR, D50 by Y. The number of neurons or units in an output layer is equal to the number of dependent variables. The output layer consists of single unit, that is ds by y. So there are 5 units in the input layer and 1 unit in the output layer. In classification problems, the number of neurons in an output layer may be more than 1 because you are classifying. Deep neural networks can also be used for classification problems. Now, there are 2 terms which are important here. One is the parameters and second is hyperparameters. Now, the parameters are the weights and biases that we determine. Hyperparameters are learning rate. What is the learning rate? You have to determine that learning rate. Number of iterations, how many iterations are required for convergence. Now you also have to choose the number of hidden layers. And then you have to choose number of units in each hidden layer. And you also need to choose an activation function. So determination of optimal values of hyperparameters is a challenging task. You see, you have to determine these hyperparameters. Hyperparameters include learning rate, number of iterations, number of hidden layers, number of units, choice of activation function. So hyperparameter optimization is used to determine optimal values of these hyperparameters. Now, to do this, there are several optimization algorithms that are available. So determination of optimal values of hyperparameters is referred to as hyperparameter optimization. In the research carried out by us, the number of hidden layers and the number of neurons in the respective hidden layers were determined using Adam optimizer. Kingma and Ba, there is a paper of Kingma and Ba of 2015, where this Adam optimizer has been explained. However, Adam optimizer itself contains several parameters. So major parameters of Adam optimizer includes learning rate, alpha, exponential decay rate for the first moments, beta 1, exponential decay rate for the second moment estimates, beta 2, and then there is a termination criteria, epsilon. So the recommended values of major parameters of Adam optimizer, Kingma and Ba 2005, alpha is 0.001, beta 1 is 0.9, beta 2 is 0.999, epsilon is 10 to the power minus 8. So these are the recommended values, and we use these recommended values. Now, ReLU function we have already discussed. It was used as an activation function in the DNN model. So ReLU function is basically fx is equal to x whenever x is greater than 0, and it is 0 whenever x is negative or 0. Or we can write fx is equal to max of 0, x. So this we have already explained. Output from the ReLU function is the input function itself when the input is positive, whereas the output is 0 when the input is negative. Now there is a library called Keras library in Python. So when you implement deep neural network, you need to have some knowledge of Python. So hyperparameter optimization based on Adam optimizer was carried out using the Keras library in Python. This library uses backpropagation algorithm to train network. And then there is a loss function, which is defined by yi minus y cap I whole square. So basically, this is the difference between the predicted value and the target value. And then we square it, sum it up, and then we try to minimize the value of this loss function. So mean square error is defined like this: yi minus y cap I whole square, and then you divide by n. So you get the mean square error. You get the mean square error. I'll show you in Excel sheet how to calculate this yi minus y cap whole square. Okay, now let us go to an Excel sheet. Okay, here. Okay. So let us try to see how this deep neural network can be implemented in Excel. This is a small problem that we are discussing here. So there are two inputs. x1 and x2. This is the length and width of a leaf, and then actual color of the leaf is either given by 1 or 0. So this is the input and this is the output we want. Simple. So there is an input x1 and x2, and the output actually is 1. Whether the leaf will be green or the leaf will be yellow. So if it is green, it is 1. If it is yellow, it is 0. So this data is given to you. Okay. Now our job is to find the values of W1, W2 and the bias, so that our network gives the value of the output 3. This output. So we want these outputs here. Okay. So what we'll do is we will first choose some values of W1, W2 and B. Any value you can choose. I can choose 1.5, let us say, some value of W1, W2 and B. And then I will calculate Z here. Z is calculated as this value x1 multiplied by W1 plus x2, which is B2, multiplied by W2, and then add the bias term, which is J3 here. So you are getting the weighted sum Z. So in this column D, we are calculating Z. W1 into x1 plus W2 into x2 plus B. And then copy this in all the cells. Copying this here. Okay. So this is Z. Next step is the Z is converted to A by using the activation function sigmoid 1 upon 1 plus e to the power minus Z. So here we are using the formula is equal to 1 upon 1 plus exponential of minus this value D2. Okay. So any question on this? And then we'll see this is the value our network is giving. And C column is what we want. What we want is in the C column, what we are getting is in column E. So the value we are getting from the activation function is denoted by A. So in column F, y minus a whole square is calculated for each set of observations, and then you sum it up. Okay. So this was this portion is the data which is given to you. And you initially put some values of W1, W2 and B. Later on, we will find out what is the optimal values of W1, W2 and B. This is our problem. We want to find out what is W1, what is W2 and what is B. So y minus a whole square, y minus a whole square here. Now, if this value is greater than 0.5, then we consider it as 1. If it is less than 0.5, we consider it as 0. Okay. So our objective is to minimize this loss, which is given in the cell F10. which is in green, basically. It is in green. Okay. So now we will use solver function to minimize this value. So we go to data, solver, and you have to minimize the F10 value. You can choose either to minimize or maximize. In the example which I discussed some time back, we had maximized. Here we are minimizing. This value in the green here by changing these values in the blue here, by changing the variable cells. So variable cells are these. You click your mouse here and then you select this 3. And since this is a non-linear problem, you will not use simplex here. You will use GRG, generalized reduced gradient non-linear function here. And then you click on solve. Solve here. So when you click solve, it will try to find values of W1, W2, and W3, some values of W1, W2, and W3, such that this is minimized. So by minimizing this, what we are trying to do is we are trying to match the desired output with the output predicted by the network. So click on solve. You see, solver has found a solution. This we can. Okay. You see, it has found a solution. The earlier value was 1.5. Now it has found it to be 2.39. W2 is this, and it has predicted the color. Actual was 1, predicted is also 1. So by adjusting the values of W1, W2, and B, the network has matched column C with column G, 0 with 0, 1 has matched with 1. Here there is a problem. It is 0 here, it is 1 here. Actually, because it is 0.52. If it were less than 0.5, it would have given it 0. So there is a small error here. This is 1 because it is 0.08. So less than 0.5, that's why it is 1. 0 has matched with 0. 1 has matched with 1. 0, there is a matching here. But here there is not a correct match. So because we are doing it in Excel and I'm doing it only, there is a limitation. So the model is not always trained 100%. Training is not achieved even in DNN model. So there is one case where we could not get the output as desired by us. We wanted 0, but we are getting 1. If this would have been less than 0.5, we would have got 0. So suppose I make it 0.49. Greater than 0.5, it is 1. Less than. No, but we have, you see, this is related to this. So if the network finds is less than 0.1, then it will correct here. But anyway, so the idea is that you try to change the values of W1, W2, and B, and you try to get the desired output. It will not always be possible to get all the training done 100%, because 100% training Uh, 100% correct training is not possible even in the network that we were implementing. Here we are just using one iteration and using solver, which may not be because we are using this GRG nonlinear function method, which is not a very reliable method. For linear problems, for linear problems, it is possible to get the global optimum solution always with solver. But with non-linear problems, it is not possible to get the optimal or the global optimal solution always. So because of this, it is in one case, it is not matching with the desired output. That's perfectly fine. If you use some other method, this is Excel I am using just to demonstrate to you. Otherwise, if you are using Keras library or some Python algorithm or MATLAB, then it will be able to find the values of W1, W2, and B such that, or maybe this is satisfied. But in practice, see here we only have 8 data points, but in practice we have hundreds of data points. So if we have hundreds of data points, maybe 95% accuracy will be obtained, where the actual output and the predicted output is same. But sometimes it is not always possible to have the 100% accuracy. It's not possible. Okay. So this was just to explain to you how you have to calculate Z, and then how you calculate A, and then Y minus A whole square, and then you predict the value of the either 1 or 0, depending upon whether the output is okay. Okay. Whether the output is less than 1 or greater than 1, or less than 0.5 or greater than 0.5. So with the help of this example, I think you would have understood how a deep neural network works. So there is a transfer function Z, which is x1 into w1 plus b, and then you have an activation function. So you are using a sigmoid activation function. It converts the value between 0 and 1, and we are saying that if E2 is greater than 0.5, then consider it as 1, otherwise consider it as 0. Otherwise consider it as to be 0. So for the Scour model, we have used the activation function, which is the ReLU function. But here I'm using, for this particular example, we were using a sigmoid function. If you remember, the sigmoid function is something like this, So it converts whatever value you input between 0 and 1, between 0 and 1. Okay. So in this presentation, I tried to cover what is Scour modeling, and then gave you some idea about optimization, and then regression modeling. And finally, we looked at what are artificial neural networks. And then we looked at deep neural networks. And then I also showed you an Excel-based implementation of the DNN. The actual DNN model is much more complex than what is shown in Excel. But with the help of this Excel model, I was able to show you how the DNN model actually works. So now with this, I come to end of my lecture, and now
Right.
So may I ask you one question first?
Yes.
Professor Sharif, thank you very much for your deep presentation. Thank you very much for your presentation today, a special lecture. Um, when you get back in the page 31, please. Yeah. So this is the example that you given to us. When you said that we will need to input the excuse me. Okay, so I like to know that for this is very interesting because I'm working with the trees, the growth of the trees, maybe in Crusoe. When we talk about the factor that we are concerned about the growth of the trees, for example, moisture level, iron level, grain size, acidity, and blah blah blah. So in the case that as we are all know that about the modeling, so the factor that concern about to most complete our modeling inputs is very important. I mean, the factors is very important to see whole things that will relevant to the answer. It seems that if we would like to model something, the thing is we should know holistic view of the factors that will be affected to the modeling, to that modeling. Yeah, that means that if we are water sectors, we need to know all factors about that's concerned about the growth of the trees. If we are, for example, the person who knows about the aircraft modeling aircraft, so we need to be the experts of the aircraft, of the airplane, or to the holistic view of this. Yeah, it is correct. So in this case, how do we know about it?
So you see,
Yeah.
this is an example of different factors which will impact the growth of tree. Now, suppose you take a large number of factors, then there is a method called principal component analysis. If you can apply principal component analysis to find out which factors are important and which factors are not very important. So significance of different factors can be found by using principal component analysis, and principal component analysis can be done using R package. There is a library in R package is called PCA. So you can use that PCA to determine which factors are important and which factors are not important. And then you can, in your model, it is always better to use only those factors that are important, because if you necessarily have large number of lab features, then it will not improve the efficiency of the DNN model. So initially you can have large number of factors which affect the performance, like in this case, the height of the tree. And then if you can conduct a principal component analysis on your data, then you will come to know which factors are important and which factors are not important.
Thank you very much. Can we get back to the picture of the scoring and the sand and the yeah, very first picture? Yes, this one. I have actually looking forward to your publication, Professor Sharif. So in your work, did you apply the scoring modeling in some area that you have work
No,
done
only
internationally?
in Scour modeling.
Uh,
I will share the paper. It's on my laptop.
yeah.
Share.
Uh,
I'll share it.
and as you
Yes.
are the expert, only you are also the expert of the genetic algorithm.
Yeah.
Do you think that the model based on genetic algorithm can be I mean is more easier or more difficult to apply to this?
See, as I told you, there are different parameters which need to be in any DNN. There are parameters like these are the hyperparameters: learning rate, number of iterations, number
Yeah.
of hidden layers. So we need to have some sort of optimization technique to find out the optimal values of the learning rate, number of iterations, number of hidden layers, number of units, choice of activation function. Choice of activation function, you can use different activation functions. Trial and error is required. But how many hidden layers would be there? How many units in each hidden layer? That you can determine by some optimization technique. So that optimization can be carried out by genetic algorithm also. But we have not tried. We have used the optimization routine available in the it's called Adam optimizer. Automatically there is an optimizer called Adam optimizer, and it is available in the in Keras library. There is a Python library that is there. So Keras library is there. We can use Keras library and try to automatically find the values of hyperparameters. Yes, we can look at using genetic algorithm to find the optimal values of hidden layers. But I don't know whether that is available in the Python library or not, because we are implementing it through Python. We're not writing our own code. So if we want to use genetic algorithm, then we have to use some sort of write our own code.
Thank you very much.
Okay. Anybody else who want to ask a question? So we can now end, and it was nice meeting you all. And I hope you have learned it. And in case you want to contact me, I think
Please give your email.
my email is here.
Right. On behalf of the Faculty of Environment and Resource Studies, Mahidol University, I would like to thank Professor Mohammed Sharif very much for sharing with us an insightful lecture today, as well as Ajahn Kampanat and all participants who joined us on Zoom. We really appreciate your attention. Thank you.